Hi, good day and welcome back to Everything Mathematics. Today we're going to wrap up this week with some practice with what we would have started earlier in respect to factorizing. We would have looked at three different strategies: factorizing by the HCF, factorizing by grouping, and we would have looked at yesterday at factorizing by the difference of two squares. So today we're going to put all those three skills together and see if we could actually handle them. So we're just going to review and practice. That's our objective. Review and practice factorization strategies we did this week. Here we have 4 questions. And of course, this is the part of the video where you could pause and attempt them on your own. But I would not pause. I would start right away. And whenever you get a factorization question, and again, before I continue and I spoil your day, you take your time right here because I'm going straight to answer. Right. Before you start solving, or rather, to be more specific, factorizing, one of the things you could do is determine which strategy you can use for each one. So for the first one, can we use the HCF? Yes, maybe, maybe not. Is there a number that could factor 81 and 16? That's one thing you could start asking yourself. But then again, you see, oh no, look at the x. There is no x here. So then HCF probably cannot work unless the numbers have a factor that could go in. Grouping, well, definitely not. Remember, for grouping, we need at least 4 terms. At least, not always, but at least. Sometimes you could get 3 and it could work out to 4. Sometimes you get 5, as we did in one of the days, I think on Wednesday, you could get 5 and you have to see how you could reduce it to 4. So that's a possibility. And then, of course, then we have the difference of 2 squares, and you say, oh, can I write 81 as a square? Can I write 16 as a square? Oh, yes, I could. So for this one, we could actually use difference of square. Difference of squares. Because it could happen. And again, you always look for the easiest way out, right? Difference of squares. Here, clearly, I think we could see grouping. Well, I could. I don't know about you. So without even examining the whole question, I see this x and this x could definitely go together. I see this y and this y could definitely go together. Down here now, okay, look at that. I'm seeing an x here, an x here, an x here. So this is most definite HCF method. Good, because they have a common factor. I'm not even looking at the numbers yet, but I see an x in all of them. So more than likely that's that. And for this one, let me see. Can I write 12 or no? This definitely cancels difference of 2 squares because there's no subtraction. There must be a subtraction for the difference of 2 squares. So that is out the window. Grouping is most likely out the window too because we need at least, as we said, 4 terms. So the only term that will most obviously work there, the only strategy would be the HCF. And this is just one way in which you could go about factorizing. Usually for CXC, you get 3 or 4 questions. They just tell you factorize, and they give you 4 different questions. This is all you need to do. Look at each one, and imagine we didn't do all the strategies yet. This is only 3 strategies. But you look at each one, and then you decide which strategy can work. And then you go from there. So now that I identify all my strategies, then it's just a simple matter of solving. So here for the 81, I know that could be written as 9 squared x squared minus 16, I know would be 4 squared. So here we have the difference of 2 squares now. This is the same as 9x minus 4 all squared. And in turn, that will be the same as 9x minus 4 multiplied by 9x plus 4. And that's that. That's that. So, one done. 3 more to go. Here we established that grouping could work. So, I could group this here because I see x squared and x squared have something in common. And I could group this here. And this one will give you a very interesting answer. And I guess it's because of the x squared. So, if I have x squared here, if I factor that out, notice I'll end up with 12 minus 5. And this is solvable. We could solve this. This is basic arithmetic. These are 2 integers, so we could solve this, but I'll come back to that. And then we have y squared. And same thing is happening here. We have 8 minus 4. because the y's cancel out the y's. And here we could easily solve this. So this is x squared, 12 minus 5, I think that is 7, plus y squared, and 8 minus 4, that is 4. And it's usually, I would say, more a matter of convention that we put the number in front. So we say the answer here will be 7x squared plus 4y squared. Good. And yeah, that's it. That's it for that one. 4x squared plus 5y squared. This one is very hard to reverse, I could tell you that, but it's possible. This one, to reverse it, we actually have to do we have to complete the square, but it's like we're completing the square and we're also doing implicit differentiation at the same time because you have two different terms. It is possible when we do, oh no, we don't do unit circles in secondary school. That's for the advanced students. But yes, when we're doing unit circles, you actually have to be able to complete the square of our x term and a y term at the same time. Yes, if we do this here, we will end up with what's at the top. I think that almost resembles the equation of a parabola because both of them are squared. But anyway, I'm going to deep into my own thoughts. Right, this, well, I know the last two we said would have been HCF. So let's see how this works out. So the common factor here is evidently x. And if we take out the x from here, we would have 19 minus 12 plus 5. And this again, we could solve what's inside there. Here we have two different operations, so I always go back to my order of operation. My preferred one is PEMDAS. So I use PEMDAS. And PEMDAS dictates that you add before you subtract. So then that means I have to add first. So that will be x into 19. If I add minus 12 plus 5, I should get minus 7. Should. And then when I find the difference here, my answer should be 11x. Yep, and that's it. Easy does it. And last but not least, so this is my final answer here. Last but not least, this one, let's see, yeah, this one is HCF again. This time the 12 is a common factor, and so is the x with the lowest degree power. So this will give us 1 plus 2x. 12 times 2 is 24. X times x will be x squared. So this is it. So that's your practice for this week. I trust this was fruitful. On Monday, we'll continue looking at the AC method, probably, or I might reconsider maybe just showing you how to file, because I think if you know to file, it's easier going forward. So maybe I should do a whole video on filing, which is mostly applicable in factorization, and also when you're doing the distributive law, you have to do a lot of that. So I might just focus a whole video on that, and then we'll continue on Tuesday with the AC method. I'll figure it out. But yes, that will bring us to the end of today. So again, as usual, subscribe if you haven't yet, share and like to help this algorithm. And until then, you take care. Enjoy your weekend.